The last thing we're going to look at quickly are attraction and repulsion, some new objects in Grasshopper called field objects. The idea being, could we take a series of points as attractors and begin to deform a grid based on what we find? So let's build a rectangular grid of points, add in an attractor, and see if we can't make something happen. Let's go to File, New. We're going to go right back to the vector menu, and if you've noticed, we've really stayed almost entirely in this menu. We've worked with points, planes, now fields and grids, and vectors. So let's drop down from the grid menu, the square grid. Now take a moment to look at what the inputs of that grid is asking for. And if you'd like, take a moment to take a look at some of the other grid objects that you have that you can use. Let's say the hexagonal grid. I'm going to go ahead and delete my square grid and use my hexagon grid instead. If you notice, you have an input for the size of the cells, the number of cells in X, and the number of cells in Y. Drop down 2 sliders, set them to integers. I'm going to call this one E for extents in X, at least 1, maybe as many as 10 or 20. And then I'm going to copy and paste that down, changing its name to extents Y or EY. Connecting my inputs and changing my slider, we'll see that we now have more cells. Now the objects we're going to use are found in vector, field. And what we need to do is actually create a field. So what we're going to do is create a field using something called point charges. The icon looks just like this, a little magnet with a point. P is asking for the location of the point charge. So if you remember, referencing points into Grasshopper allows us to create points in Rhino and then bring them into Grasshopper for use. This time, instead of creating one point, I'm going to right-click to create multiple points in Rhino. Creating a point container in Grasshopper, let's right-click and set multiple points. This time, I'm able to select multiple points at once and have them live inside of this one container. Connecting the output of this into P, you can see that we now have icons in Rhino showing that this is now a force. Now what we're going to do is take our hexagon and we're going to look for some relationship of this hexagon to the attractor. Now these hexagons are actually closed polyline cells. And so from curve, we can always analyze an object like a polyline for its center. Here you can see polygon center. What I'd like to do is take my cell, which is designated as C, and calculate its center. Using the center of the cell, I can now see how to make a relationship between what I found here and this object. Now one thing to note, down here at the origin, we have what is referred to as a construction plane. These are the cells. You can change the scale of your construction plane by going to View, Display, Preview Plane Radius, and changing this maybe to 0.5. When working with fields, you have to make a relationship or put a relationship in place between a point and a charge. What we're going to do is evaluate the field at a point. The point we would like to evaluate is what's coming out of here, the center calculated from our edges. But before F goes into F here, we're going to use an object called merge fields. You don't have to take this step here, but it's nice because if you were using more than one attractor, you could actually merge multiples into this object. So let's go ahead and do this just so you're familiar with this object. This is merge fields. I'm going to take that into F. And now what we have out of S is the strength at that sample location. So let's say, for instance, what we'd like to do is take our cell and scale it using the strength. Scaling is a transformation of a theme type. So I'll take the scale object and drop him down. You notice it asks, what would you like to scale? I'd like to scale my cell. It asks, what is the center? We know that this is our center here. All of them are scaling by 0.5. But what we'd like to do is scale them using our strength here. But if we drop in a panel really quick, we'll see that the values here might not make a lot of sense for scaling. So the last thing we're going to do is take a look under the Math tab, under Domains. This is a great tab, and you'll find so much stuff here for you to use as you're modeling. When we created the range, or created a sequence of values with the range, we used the domain input with a slider. You can also define a domain by minimums and maximums. But more importantly for us, you can take any current value and remap it. So if the values that you calculate don't really work for what you're trying to do, you can always take that value into V and redefine what you would like its target to be. So right now, we have to first figure out what is the domain of all of the strength values, and then define what we would like it to be. So what we're going to do is we're going to drop down the domain object. Remember, a domain is the space between a minimum and a maximum. So I'm going to say minimum, min scale, max scale. And I'm going to take that into T. T is my target. But in order to take a value from its current range and remap it into a target range, we need to know what is our current source domain. If we go to domain, you can see at the very top there's an object called bounds. And bounds will calculate what domain encompasses a list of numbers. Now, where we're heading in the next webinar deals with data trees. And you might notice as I'm modeling, my wires are changing. This means that there's a data tree that's growing. Let's take S into N and zoom into N and right-click on its input. Sometimes in Grasshopper, you have to actually change the structure of data as you're modeling. Here on N, we're going to flatten, using the flatten option, the data tree, which we'll talk about more in the next webinar, so that we can get just one numeric domain. That will be S. We now have all of our factors for scaling. And if we turn off some previews, we can start to see that as these points move, the scale of our objects will be effective. Now, if we want to see more change in our field, we can always use this last object that we'll look at for input called the graph mapper. And this is a really awesome object, graph mapper. So we'll just take this object, right-click on the gray area, and change the graph to Bezier or Bezier. You'll notice, just like the slider, it has handles or grips, and you can move them around. And we could take the current value and pass it through this before we give it to scale. Allowing us to intensify this locally, right? More or less. If you'd like to drop in from surface, freeform, planar surface, you can kind of visualize that as a surface. Awesome. Now, so what we're really working with are vectors, and we're going to have a whole webinar dealing with advanced topics on vectors, but basically what it is a direction and a magnitude, and we're calculating what the relationship is of points in space to a force, and using that force to begin to create difference within the field.